So today we will answer some questions related to the topics that we have covered. The first question, metallic spring obeys Hooke's law. Sketch a graph to show the spring obeys Hooke's law as it is stretched. You should label both axes with the appropriate physical quantities. So first let's revise this topic. This topic is related to studying the relation between force and the extension of a spring. So if we have a spring and this spring is attached to a hook and it is just fixed vertically by using a holder or something like this. So how can we study the relation between applying a force to the spring and its extension? This is the method of doing this practically. First of all, you need to fix a ruler, just a tool to measure the length, and you will find out the initial length of the spring, maybe till this part. And this will be the initial length. Let's call it x1. After adding some masses, for example, a mass of 10 gram, a mass of 10 gram, of course, this spring will be stretched. So maybe this will be its new length till this part. So in this case, you will measure the length for the second time from the beginning to the new extension. And let's call it x2. To find the value of the extension, we are interested in this part. How can we find this part? This part is called delta x, or the extension. So in this case, we will need to subtract the old reading, which is x1, from the new reading, which is x2. For example, if this one is 10 centimeter and the previous one was 4 centimeter, so in this case, we will do 10 minus 4. So the new extension due to this mass is 6 centimeter and so on. Then we will repeat the experiment with different masses. For example, 15 gram. Then we will find the extension by using the same technique. Then we will remove it so that the spring will restore its original shape. Then we will use 20 gram and so on. Then we will arrange our data in a table which shows the relation between the force, which should be measured in Newton, and the extension, which is delta x, which should be measured in meter. But we have some conversion problems. The first problem that we have the mass. And how can we get the weight, which is the gravitational force, from the mass? First of all, the mass should be converted from gram into kilogram. To divide the mass from gram into kilogram, you need to divide by 1000. So the mass is just 0.01 kilogram. To find the weight for the corresponding mass, because weight represents the gravitational force, you need to multiply mass times the acceleration due to gravity, which is equal to 9.8, 9.81, or we can use the approximated value, which is 10 meter per second squared. So the weight for this corresponding mass will be 0.01, which is the mass in kilogram, times g, which is approximately equal 10. So this one will be equal 0.1 Newton. So this is the force. So this was the force, the first force. And the corresponding length, according to this measurement, was about 6 centimeter. But we have another problem. The extension should be in meter. How can we convert the displacement or the extension from centimeter into meter? By dividing this extension by 100, because each 1 meter contains 100 centimeters. So it is 0.06 meter. So we will find that if the mass is doubled, of course the force will be doubled, and also the extension will be doubled. And if it is tripled, the extension also will be tripled. And if it's quadrupled, the extension also will be quadrupled, and so on. But this is to a certain limit. When the mass exceeds a certain limit, the spring will not be able to return to its original shape after removing the force. This means that this spring is not elastic anymore. So when we try to just draw the relation between the applied force which is the independent variable. Why this is the independent variable? Because this is the physical quantity that we keep changing. And with the extension, which is the dependent variable. Why this one is the dependent variable? Because its value changes according to the value of the applied force. We will find that the relation between them is represented by a straight line. For example, 0.1 corresponds 0.06, 0.2 from the table, right? Corresponds 0.12, 0.3 is in front of 0.18 and so on. But we will see that after a certain limit, this straight line is not straight line anymore, and it starts to form a curved line. It is not linear anymore. So this is a non-linear graph, but it is a linear graph until a certain limit in this part. In this part, the springs obeys Hooke's law, but after this, in this region, the spring does not obey Hooke's law because it just loses its elasticity. It is not elastic anymore. Now, it just loses its ability to restore its original shape after removing the force. So we will discover that the extension is directly proportional to the applied force. We can substitute for the proportionality sign by two things, by constant and equal sign. We call this constant is k, but in fact, for this relation to be correct, because I put x over the y-axis and f over the x-axis, it should be 1 over k times f. After doing cross multiplication, we will find that f is equal to k times x. But we have a problem. If the direction of the applied force is downward, this is the weight, so its direction is downward, the restoring force is trying to pull the weight upward. So this is the direction of the displacement. This is the direction of the restoring force. So this is the reason that Hooke's law contains the negative sign. Negative sign represent that this is a restoring force. What does it mean? It's a restoring force. It tries to restore the original shape of the spring to its original position before applying the force when the force is removed. So this means that if you are just trying to compress the spring, so the restoring force will push down. If you try to stretch the spring, so the restoring force is trying to push up. So the direction of the restoring force is always in the opposite direction of the displacement. This is the reason that Hooke's law contains this negative sign. So in this case, if you just try to calculate the slope, it will be equal to delta y, which is the extension, over delta x, which is the force. So in this case, if you just move this force to the other side and k to this side, you will find that it's equal to 1 over k. K is called the spring constant. But if you want the slope to be equal to the spring constant directly, direct without just doing 1 over, in this case, you need to draw the force over the y-axis and the extension over the x-axis. In this case, when you find the slope, it's equal to delta y over delta x. So it's equal to delta force over delta extension, which is equal to the Spring's constant. Spring's constant. And this spring constant depends on the material from which we have created the spring. So the independent variable is the force. The dependent variable is the extension. And we can have some control variables like the material from which the material that we are using just to make the spring. We are trying to use two identical springs which having the same spring constant. Just to we will try to use the same masses if we are comparing between two springs, just to make the test fair as we can. So now you know how to perform the Hooke's law experimentally and how can you measure the extension. So what is the method that we are using to measure the extension, first we need to measure the initial length of the spring before applying the force. After adding the mass, the extension will expand. We will find the new length. Then we will subtract the two numbers and we will find the new extension due to the added mass. We will arrange the data in a table. Then we will plot the relation between force and extension. If we try to find the slope, if force is over the y-axis and the extension over the x-axis, the slope will represent the spring's constant. Okay, this is Hooke's law. So let's try to answer this question. So for this question, we need to draw the variables. So it's up to you. You can just add here the force in Newton because this is the independent variable, and add the extension here in meter because this is the dependent variable. In this case, you will find that the relation between them is represented by a straight line. But as I told you, it will not be straight line forever. After a certain limit, after the elasticity of the spring has been exceeded, it will change into a curved line. So in this green region, the spring will not obey Hooke's law. The spring will obey Hooke's law in this red region only. Okay? But what if you want just to represent the extension in meter over the x-axis and the force in Newton over the y-axis? Yeah, you can do it. In this case, the slope will be equal to spring's constant. But in this case, the slope will be equal to the reciprocal of the spring constant. It will be equal to 1 over k. For question B, diagram 1 shows an object which is suspended from a support using a metallic spring. The object is initially at rest. Initially at rest means its initial velocity is 0. And also it means the sum of all forces which are acting on this object is 0. This is Newton's first law. So for question I, the object is pulled down. So now we have force. Now the sum of all forces is not equal 0. This is Newton's second law. Then it is released. Diagram 2 shows the forces acting on the object at the instance of release. As you can see, we have a down force, which is 2 Newton, and up force, which is 3.2 Newton. Determine the magnitude. Magnitude means the value and the direction of the resultant force. So as you can see, this is the positive y-axis and this is the negative y-axis. To find the sum of all forces, we will take each force with its corresponding sign. Since this one is pointing up in the direction of positive y-axis, so it is positive 3.2. And this one is pointing down in the direction of negative y-axis, so it's negative 2. So the difference between them is just 1.2 Newton. This is the net force. What does it mean? It means that we can just use the same object, but instead of just using two forces to act on it, we can just use one force. Its value is 1.2 Newton, which points up, and it will produce the same effect done by the two forces. This is the reason that this force is called the net force, or sometimes it's called the resultant force. What's meant by the resultant force? It is a single force which produces the same effect done by two forces or more. So what is the magnitude of the force? You need to show your work. You will write 3.2 positive because it's upward, minus 2 because it points downward. So the final answer is 1.2 Newton. And what is the direction of this force? It is up or upward. You can use your words, okay? It's upward. Why? Because as you can see, the force which was pointing up is greater than the force which was pointing down. So the resultant force will be upward. How can we calculate the acceleration? We can calculate the acceleration from Newton's second law. Newton's second law states that if you have a resultant force, the object will acquire an acceleration. This acceleration is directly proportional to the resultant force. So this means that if you are acting on an object by a greater resultant force, it will gain a higher acceleration. But at the same time, it is inversely proportional to its mass. This means that if the object has a smaller mass, it will gain more acceleration. So To calculate the acceleration, you need to find the resultant force. We already calculated it. It was 1.2 divided by the mass, which is given in double I, which is 0.2 or 0.20. They are the same. Then you will divide 1.2 divided by 0.2. It will be 6. Since this one is acceleration, its measuring unit is meter per second squared. So this is the acceleration due to the resultant force. For this question, triple I, explain how the magnitude of the acceleration of the object changes from the instant the object is released until the first time the object returns to its initial resting position. At the initial resting position, its final velocity becomes 0. It is not vibrating anymore. So when the object was stretched, the extension was maximum. After releasing it, it will keep vibrating up and down. But as you know, the amplitude of vibration will decrease until it comes to rest. So the amplitude of vibration decreases because the spring will lose its energy. This energy will be converted to another form of energy, right? You should refer to the forces acting on the spring in this point. You know that the sum of all forces which were acting on this spring was equal to 3.2 minus 2, right? We will consider this 2 maybe as the weight of the object, maybe as the weight of the object. And was the stretching force. So this means that this force, this difference, keep decreasing until the sum of all forces becomes 0. And since the acceleration is equal to the sum of all forces divided by mass, and since the mass is constant, this is the same mass, and the net force just decreases, the acceleration decreases until it becomes 0 at the end. Okay? So how can we explain this? So we can say, according to Hooke's law, the restoring force is equal to negative kx. So as you can see, the extension of the spring decreases, and the net force acting on the spring decreases, but its weight is constant. The weight of the spring, the gravitation force is constant. So the acceleration decreases until it reaches 0. So the extension decreases, resultant force acting on the spring decreases, acceleration decreases until it reaches 0. Then use your own words just to change these symbols into full sentences. Okay, this is for the first question. Let's move to the second question. For the second question, it's related to pressure. So let's try to explain the part which is related to pressure. We said that pressure is equal to the average force which acts perpendicular on a unit area. So if this is the area, and you have a force which acts normally, which means it makes an angle 90 on the surface. If you want to find the pressure which is exerted by this force, for example, by your weight, for example, if you are standing on this area, you will find your mass, then you multiply it by the acceleration due to gravity. So this is the weight, and you know that the weight is acting vertically downward toward the center of the earth. And you will calculate the area that you are standing on. If this is a circle, so we need the radius. So in this case, it will be pi r squared. To find the pressure, you will divide the force, which is your weight, divided by the area. You will find the value of the pressure. And you know that the measuring unit of the force is Newton, and that of the area is meter squared. So the measuring unit of pressure is equivalent to Newton over, which is read as per meter squared. And this is equivalent to another unit, which is called Pascal. So the measuring unit of pressure is Pascal or Newton per meter squared. and the pressure is just the force which acts perpendicular on a unit area. So, for this question, during an aeroplane flight, a passenger drinks some water from a plastic bottle. The passenger then replaces the top to seal the bottle, as shown in the diagram 1. The air pressure outside the bottle, you know that pressure is a scalar physical quantity and it acts in all directions. So the pressure due to air, which is called atmospheric pressure, is acting on the bottle from all directions, and the pressure is equal to 10 K means kilo, PA means Pascal, so this is 10, it's 80 kilo, kilo means 1,000, so it is 80,000 Pascal. This is a huge number. So state the air pressure inside the bottle. By the way, as you can see, the bottle has its shape. It is not compressed, as you can see. So this means that the external pressure is equal to the internal pressure. There are air molecules inside the bottle, right? And they are moving randomly and they are keeping colliding with the walls of the container. But as you can see, there is no deformation in the shape of the bottle. So this means that the internal pressure is equal to the external pressure. And since the external pressure is 80 kilopascal, this means that the internal pressure is also 80 kilopascal. And the net pressure is equal to 0 because the external pressure is equal to the internal pressure. So they will cancel out. This is the reason that there is no deformation in the shape of the bottle, right? For question B, as aeroplane descends, means it lands, its height from the ground decreases, starts landing. The air pressure inside the aeroplane changes. When the aeroplane lands, so now the aeroplane is on the ground, the passenger notes that the plastic bottle has collapsed, as shown in diagram 2. Explain why the bottle has collapsed. Do you remember that the passenger just sealed this bottle when the aeroplane was flying? And you know that if this is the sea surface and this is the end of the atmosphere, if you are standing on the top of the mountain, so this is only part of the air above your head. But if you are standing at the sea level, so all the air is sitting off above your head. So this means that while you are at the sea level, you are experience more pressure if you are at the top of mountain, right? So this means that the pressure when the aeroplane was flying was equal 80 kilopascal, right? So this means that the pressure inside the bottle is kept at 80 kilopascal. But when the aeroplane just landed, the external pressure, now we are at the sea level, right? The external pressure now is more than 80 kilopascal. So this means that there is no balance anymore. This means that the external pressure now is more than the internal pressure. So this is the reason that the bottle just collapsed, because the external pressure now becomes more than the internal pressure. So we will say the pressure inside the bottle is still 80 kilopascal. But, so this is the first point, but the external pressure, you can say after landing, becomes more than 80 kilopascal because the aeroplane just landed, right? So there is more air column above the aeroplane, right? So this means that the external pressure is more than the internal pressure. So the volume, so the volume of the air inside the bottle will decrease. Why? Because the pressure has increased, right? So this is the answer. For question C, explain how gas molecules in the air exert a pressure on the surface of the bottle. You know that this is the bottle, and this bottle just is trapping some air molecules. And you know that molecules, they are in continuous motion. They are moving randomly in all directions. So they are keep colliding with the walls of the container. And you know that pressure is equal to the force over the area. So the molecules, while they are hitting the walls of the container, they are causing pressure. So we can say this is the 3-mark questions, huh? Be careful. So we'll say air molecules are moving randomly. This is the first point, okay? Colliding, colliding means hitting. Colliding the walls or colliding with the walls of the bottle. And since pressure is equal to the force which acts perpendicular on a unit area, so they create pressure. So this is the answer of this question. For this question, a light bulb used in homes converts electric energy into light energy, the input power. So we need to revise the part which is related to power and energy. We know that power, if this is electric power, it's equal to I times V. I is the electric current intensity, which is measured in ampere. V is the potential difference or the voltage, which is measured in volt. Also, power, it is the rate of the consumed energy. So you can write E or W. W stands for the work, which is measured in joule. T stands for time, which is measured in second. E stands for energy, which is measured in joule, and T stands for time, which is measured in second. So the unit of power is equivalent to joule per second, which is equivalent to another unit, which is called watt. Okay. So how can we calculate something which is called efficiency? Efficiency is just the percentage, is just the ratio between the output power divided by the total input power, and we multiply everything by 100 to convert it into percentage. Or this is the useful energy. You can replace power by energy because time will be cancelled out. And this is the total energy. So there is another formula which is useful energy divided by total energy times 100. But this is not energy, this is power, okay? But you know that power is equal to energy over time. So energy over time in the numerator, and down there we have energy over time. So time will be cancelled out. So this is the useful energy and this is the total energy, okay? So let's try to answer this part. So we have a light bulb which is used in homes to convert electric energy into light energy. The input power, so this is the total power. This is the total input power is equal to 52 watt. W stands for watt, which is joule per second. The efficiency, which is eta, this is a Latin symbol, which is equal to 5%. 5% is equal to 5 over 100. In a decimal form, it's just 0.05. So if 5% only just is converted into light, that the remaining part, which is 95%, 95 over 100, which is 0.95, will be converted to another form of energy, and it will be heat. So the question is asking you to calculate the amount of light energy. It is not power, it is energy output by the lamp in 9 hours. Just figure out the value of energy or the useful power, then we can move to the second step. So you know that the efficiency, which is eta, equal to the ratio between the output power for the input power. So this is over 1. Let's do cross multiplication. Cross multiplication, we'll do the product of the two extremes is equal to the product of the two means, right? So the output power equal to the efficiency times the input power. So in this case, the output power is equal to the 5%, which is 0.05, or 5 over 100, they are the same, times the input power was 52. So this means that the output power in this case is equal to 0.05 times 52. So only 2.6 watt of the total power is converted into light. And the remaining part, which is 52 minus 2.6, just converted into heat. But we are not interested in power. We are interested in energy. We said that here, energy divided by time is equal to power. So we can just say energy divided by time is equal to power. So if you are interested in energy, you can cover it with your hand and you will find that it's equal to power times time. The power, which is converted into light, is 2.6. The time should be in seconds, but you have 9 hours. You need to multiply this number by 60. So now you have converted it into minutes. So each hour contains 60 minutes, but each minute contains 60 seconds. So you need to multiply by another 60 to convert it into seconds. So you will do 2.6 times 9 times 60 times 60. So the final answer is 84,240 joules. Done. But if the question needs the answer in kilojoule, you need to divide this number by 1000. F. Okay. So in this case, it will be 84.24 kilojoule. But since the question is asking you about to find the answer in just joule, so you will keep the number as it is. If the question is asking you just to find the result in the form of two significant figures, so in this case, it will be 84,000 joule. But you need to just read the instructions. There is no given instructions for the output value, so you can keep it as 84,240 joule. For this question is related to electricity and Ohm's law. So let's figure out how can we revise this part. Any electric circuit is formed from a source of energy, which is a cell. If we have this shape, this is one cell. If we have more than one cell, it's called battery. And we have a switch. This is open switch. Now this is a closed switch. And we can have a variable resistance, or it's called a rheostat. This is the slider. And this zigzag line is the resistance. So the whole part together is called variable resistance. You can just control its value by moving the slider. And there is a device which is connected in series. It's called a meter, just to measure the current intensity. And this is a fixed resistance. What is the difference between this one and this one? This fixed resistance, you can't change its value. It's fixed, it's constant. But this one, you can change its value by moving the slider to the left or to the right. If you want to change its value, you want to increase its value, you can move it to the left. If you want to decrease its value, you can move it to the right. Then you can close the electric circuit. How can you measure the potential difference between the two terminals of this fixed resistance? You connect another device, which is called voltmeter, but this one is connected in parallel. But this one is connected in series. This one is connected in series to measure the current intensity. This one is connected in parallel to measure the voltage. The voltage is measured in volt. The current intensity is measured in ampere. To calculate the value of the resistance, we use Ohm's law, which states that the ratio between the voltage, or the potential difference between the two terminals of the resistance, divided by the current intensity is a constant value, which is the resistance, as long as the temperature is kept constant. But if the temperature is not constant, the relation between them will not be linear. So you just draw the relation between the voltage and the current, because this is the independent variable, this is the one that you change, and this is the dependent variable, this is the physical quantity which changes according to the independent variable, you will find that the relation between them is represented by a straight line. But if the temperature is not constant, this straight line will not be straight line anymore. So in this case, Ohm's law is not valid, and the relation is not linear. So if you want to find the slope of this one, you will find I over V, which is equal to 1 over the resistance. But if you want to calculate the resistance direct from the slope, in this case, you need to draw the voltage in volt over the y-axis and the current in ampere over the x-axis. You will find that you will have a straight line, and the slope of this straight line will be equal to V over I, which is equal to R. This is Ohm's law. As we said, the measuring unit of the voltage is volt, current intensity is ampere, and the electric resistance is ohm, and its symbol is just omega. So let's try to answer this part. A teacher uses this circuit to investigate how the current in a circuit changes with temperature at the room. We said that as the temperature increases, the value of the resistance changes. So it is not zero. It changes. Delta means there is a change. So this means that Ohm's law will not be valid, or the relation will not be linear, right? Calculate the voltage across the thermistor. What's meant by thermistor, by the way? Thermistor, this is the symbol of thermistor. It's a rectangular shape, just like the resistance, but with this inclined line. This means that it is a variable resistance, but you don't need a slider to change its value. You need heat to change its value. So it is a resistance which you can control its value according to the temperature of the surrounding. So how can you calculate the voltage across the thermistor? You need to have a voltmeter which is connected parallel to it for the thermistor. How can you calculate its value? This is the total voltage of the circuit. The total voltage of the circuit is called EMF, which is called the electromotive force, or VB, or the voltage of the battery. Since the voltage of the battery is 1 volt, so this is the total voltage of the source, this voltage should be consumed in the components of the circuit. How many components that we have? We have a fixed resistance. This is a constant. Careful with this word, constant resistance, and the thermistor. Since the fixed resistance just consumed 0.91, so the thermistor will consume the rest of the voltage. So the voltage of the thermistor will be equal to the voltage of the battery, which is the electromotive force, minus the voltage of the fixed resistance. The total voltage is 1.5. The voltage of the thermistor is 0.91. So if you subtract the two numbers, 1.5 minus 0.91, this is the voltage which will be consumed across the thermistor. So it's 0.59 volt. So this is the answer. And you need to show your work, okay? For double I, state the formula linking the voltage, current, and the resistance. This is called Ohm's law. This is the formula which links the resistance, voltage, and current. So you can say V is equal to I times R, or you can just draw this triangle. V is equal to I times R. Calculate the resistance of the thermistor. To calculate the resistance of the thermistor, we have to use Ohm's law, although the temperature is not constant, but we can use the instance voltage and the instance current. So R is equal to V over I. We have calculated the voltage in I. It was 0.59. And you can find the value of the current intensity from the circuit. As you can see, it's 6.2 milliampere, and this is the same current which is passing through the thermistor and the resistor because they are connected in series. So they have the same current intensity. So the current in this case is 6.2, but we have a problem. It is in milliampere. So to convert from milliampere into ampere, you have two options. You can divide by 1000 or multiply by 10 power negative 3. They are the same. So times 10 to the power negative 3. So in this case, you will divide this number by 6.2 times 10 power negative 3. And if you just do this, you have to put them in a bracket, or you can just write them in a fractional form. So the answer is 95.16. 95.16 ohm. So this is the resistance of the thermistor. And by the way, the resistance of the thermistor will change according to the temperature, as you can see from question B. For question B, the graph shows how the resistance of the thermistor changes with the temperature. As you can see, if you look at the x-axis, as the temperature increases from left to right, the resistance of the thermistor decreases. So this means that there is an inverse relationship between resistance and temperature. What does it mean? It means that as the temperature of the thermistor increases, its resistance decreases. So they are called inversely proportional. Describe the relation between the temperature of the resistance of and the resistance of the thermistor. We already explained this. So the short answer is R is inversely proportional with temperature. So if you want to write it, we can say as the temperature increases, the resistance of the thermistor decreases. And you can write, because they are inversely proportional. For double I, explain how the reading of the voltmeter changes when the temperature of the room decreases. Okay, this is a good question. Can you see this voltmeter? Its reading is equal to I times R. R, pay attention because this is a tricky one. R of this resistance will be 140 ohm because it is a fixed resistance. It will not change. So the factor which will affect the reading of the voltmeter is the current of the circuit. How can we calculate the current which passes through the circuit? Pay attention. According to Ohm's law, I is equal to V, which is the voltage over the total resistance. And pay attention to the word total resistance. How many resistors that we have in this circuit? We have two. The first one is the resistance of the thermistor. And the second one is the fixed resistance or the constant resistance. This resistance is constant, so it will not change. It will be 140 ohm. And you are saying that the temperature of the room decreases. We said that as the temperature of the room decreases, the resistance of the thermistor increases because they are inversely proportional. So this means that this part will increase. So this means that the denominator will increase. So this means that the value of the total current will decrease because, as you can see, I is inversely proportional with the total resistance. Part of the total resistance is constant, but the other part will increase. So the total resistance will increase, right? Perfect. The second part of the answer. Since the reading of voltmeter is equal to I times the resistance of the fixed resistance, which is 140 ohm, and we discovered that the value of the current intensity will decrease because the total resistance will increase. This means that the voltage also will decrease because the voltage is directly proportional with the current if the resistance is constant. So how the resistance is constant and you are saying that the total resistance will increase? Yeah, you need to differentiate in this question between multiple parts. The first part you need to distinguish the RC. This is the constant resistance. It's 140. It will be 140 ohm. The resistance of the thermistor, this one will increase when the temperature decreases. And the final resistance is the total resistance, which is equal to the sum of the two resistors. This part is constant, but this part is increasing, so the total will increase. Okay, and as the total resistance increases, the total current will decrease. So how can we write the answer? To save the time, I will just say it, and you can write it after me. So you will say, as the temperature of the room decreases, the resistance of the thermistor increases. So this is the first part. This is the first point, because this is a 3-mark question. And since from Ohm's law, I is equal to V over total resistance, and the total resistance is the sum of the resistance of the thermistor plus the constant resistance. So the total resistance increased and the total current will decrease. And since according to Ohm's law, the voltage and the current are directly proportional, since the current intensity has decreased, the voltage also will decrease. So the final answer is the reading of voltmeter will decrease. Why? Because the total current intensity has decreased. Why? Because the total resistance of the circuit has increased. Why? Because the total resistance is equal to the sum of the resistance of the thermistor plus the constant resistance, and the resistance of the thermistor has increased, so the total resistance increased. So why the resistance of the thermistor has increased? Because the temperature of the room has decreased. Why? Because they are inversely proportional. Can you see? This is the way of thinking. This is not an easy question, but you will be happy when you understand this type of questions. This question, the photograph shows a brass mass. State the formula linking the density, mass, and volume. So let's take this object and let's try to revise this part. This part is related to density. The formula that we are using to calculate the density is equal to the ratio between the mass of the object and its volume. This is the mass, which should be measured in kilogram. This is the volume, which should be measured in cubic meter. So the measuring unit of density is kilogram over, which is per meter power 3, or kilogram dot meter to the power -3. So it's kilogram per cubic meter or kilogram dot meter power -3. Or we can use smaller units. For mass, it can be gram, and in this case, for volume, it will be cubic centimeter. So the measuring unit of density is gram per cubic centimeter or gram dot centimeter power -3. To convert from gram per cubic centimeter into kilogram per cubic meter, you multiply by 1000. And to convert from kilogram per cubic meter into gram per cubic centimeter, you will divide by 1000. For example, the density of water is 1 gram per cubic centimeter, but also it's equal to 1000 kilogram per cubic meter. The density of copper is 8800 kilogram per cubic meter, but it's also equal to 8.8 gram per cubic centimeter. So you can use this conversion to convert between the two units. But the question is, if we have this irregular shape, what is the method that we can use just to calculate its volume? In this case, we can use a method which is called water displacement. So what is the method? You will bring a graduated cylinder, and in this graduated cylinder, you will put a suitable amount of water, and you will find its initial volume. For example, 100 cubic centimeter. So this is volume 1. Then you will add this shape inside this graduated cylinder. So what will happen to the level of water? Of course, the level of water will increase. So you will take the second reading, but be careful. Your vision, the way of taking the number, you should see the reading in the plane of the vision to avoid error, to minimize error. Okay. So this is the second volume. This is volume 2. And this is the volume of this object and the water. For example, it is 300 cubic meter. How can you find the volume of the object itself? You will just subtract the two numbers. You will do volume 2 minus volume 1. Done. So in this case, it will be 300 minus 100. So it will be 200 cubic centimeters. So this is the way you can use just to calculate the volume of a regular shape. What if you want also to calculate its density? So you will do these steps, then you will use mass scale to find its mass in gram. For example, it will be 500. So how can you, this is the final step, how can you calculate its density? You will do mass over volume. So it will be 500 divided by 200. This is the volume. So it will be 2.5. Since the mass in gram and the volume in cubic centimeter, so the unit will be gram per cubic centimeter. And of course, it will sink in water. Why it will sink? Because its density of this object is more than the density of water. Because its density is 2.5 while the density of water is just 1. And anything which has a density higher than water, it will sink in water. Okay? Also, we have studied some relation related to gas. And we said that the difference between gas and liquids is that gases are compressible. Compressible because they have large intermolecular spaces. So we can force them just to take smaller volume. And we discovered that there is an inverse relation between pressure and volume at constant temperature. This is called Boyle's law. So as the pressure of a gas increases, its volume decreases, but on one condition, the temperature remains constant. Also, we discovered that the volume is directly proportional to temperature, but this is also on one condition when the pressure is kept constant. This is called Charles' law. And this is logic because if you have a piston, for example, like this one, movable piston, so it's free to move. And we have some air or gas particles here, and you are trying to heat them up. The molecules will gain more kinetic energy. So the number of collisions with the walls of the container will increase. This part is not movable. This part is not movable. This part is not movable, but this part is movable. So the molecules will keep pushing in this direction, so the piston will move up, so the volume of the gas increase. And in all cases, the pressure was equal to the atmospheric pressure, so the pressure is kept constant. So as the temperature of a gas increases, its volume will increase as long as the pressure is kept constant. The final relation is the pressure is directly proportional to temperature, and I think that you know that what's the condition when the volume is kept constant. So as you can see, we are playing with three physical quantities. We are keeping one of them is constant each time, and we play with the other two physical quantities. This is called pressure law or Joules's law. So this means that if you have a fixed volume, container of fixed volume that contains an amount of gas, and you try to heat it up, so the molecules kinetic energy will increase, so the number of collisions will increase, so the pressure of the gas will increase as the temperature increase. But which scale we are using the temperature in this formula? It's called Kelvin scale. So you know that we have the regular temperature scale, which is called degrees Celsius, in which water freezes at 0 degrees Celsius. This is also called the melting point of ice. This is the melting point of ice. And 100 degrees Celsius, which is called the boiling point of water. But we have another scale, which is called Kelvin scale, in which this temperature, which is the melting point of ice, is equivalent to 273 Kelvin, and this boiling point of water is equivalent to 373 Kelvin. So as you can see, this scale is divided into 100 divisions, and this scale also is divided into 100 divisions between the melting point and the boiling point. So if we just give the symbol of the degree in Celsius, small t, and the temperature in Kelvin as capital T, we will find that capital T, which is the temperature is Kelvin, is equal to the small t, which is the temperature in Celsius plus 273. Because as you can see, if you add 273 to 0, you will get 273. If you add 273 to 100, you will get 373. So if you are given the temperature in Celsius and you want to convert them into temperature in Kelvin, in this case, you will take the temperature in Celsius and add 273 to it. So it will be 296 Kelvin. So 296 Kelvin is equivalent, is the same as 23 degrees Celsius. But what if you were given the temperature in Kelvin and you want to find the temperature in Celsius? In this case, you will just do small algebra. You will just take this number and move it to the other side after changing its sign. So it will be the temperature in Kelvin minus 273. So it will be 300 in this case minus 273. I think it will be 27 degrees Celsius. This is how can you convert between temperature on the Celsius scale and on the Kelvin scale. Kelvin scale temperature is equal to the temperature in the Celsius scale plus 273. Temperature on the Celsius scale is equal to the temperature on the Kelvin scale minus 273, and so on. This is important for gas laws. For gas laws, P1 over P2 is equal to V2 over V1 because they are inversely proportional when the temperature is constant. This is called Boyle's law. V1 over V2 is equal to T1 over T2. This is correct when the pressure is constant. This is called Charles' law. And the temperature here should be in Kelvin. P1 over P2 is equal to T1 over T2. This is correct when the volume is constant, and this is called pressure law or Joules's law. And this is also should be in Kelvin. Finally, we have something which is called general gas law, which is the product of the pressure of any gas times its volume divided by the temperature on the Kelvin scale is a constant value. So in this case, it will be P1 V1 over T1 is equal to P2 V2 over T2. But you will not need this relation, but this is just in general for advanced questions. So let's move to this questions. State the formula linking density, mass, and volume. We said that density is equal to mass over volume. And if you are not happy with the symbols, you can just write density equals mass over volume. It's up to you. For question B, the brass mass has a mass of 454 grams. If you want to convert it into kilogram, you need to divide this number by 1000. So in this case, it will be 0.454 kilogram, but I think it is not needed. Because can you see the density is in gram per cubic centimeter? So this means that you should keep the mass in gram, okay? And the density of the brass is just 8.46 gram per cubic centimeter. Calculate the volume. You know that from the formula of the density is equal to mass over volume. So if you are interested in the volume, you will do mass over density. Mass is equal to 454. Density is equal to 8.46. So in this case, you will use your calculator and you will divide the two numbers. 454 divided by 8.46. So the answer is 53.66. And the unit is gram. No, this is volume. So the unit is cubic centimeter. Why it is cubic centimeter, not cubic meter? Because the unit of density is gram per cubic centimeter. So this means that the mass should be in gram, which is in gram. So the volume should be in cubic centimeter. So the answer is 53.66 and the unit is cubic centimeter because this is volume. For this question is about electromagnetic waves. So let's revise the electromagnetic waves. For the electromagnetic waves, what's meant by electromagnetic waves? They are waves which are produced from the vibrations of electric field and magnetic field which are perpendicular to each other and perpendicular to the direction of wave propagation. We have something which is called electromagnetic spectrum, in which we have all the electromagnetic waves which are arranged according to the wavelength, frequency, energy, and so on. So we see only a narrow part of the electromagnetic spectrum, which is called VL. VL stands for visible light. And we discovered that the visible light, which is the white light, is just a mixture of 7 colors, which are rouge, vif. This is the first letter from each color. So it's red, orange, yellow, green, blue, indigo, violet. Before this region, which is visible light, we have 3 other regions. And after this, we have also 3 other regions. This color is called red, right? So the region before it is called infrared. This part is called violet. So the region after it is called ultraviolet. So IR stand for infrared. UV stand for ultraviolet. After ultraviolet, we have X-rays. And finally, we have gamma rays. This is gamma. This is X. Before infrared, we have microwaves. This is called microwaves. And finally, this is the least electromagnetic wave in energy. It's called radio waves, which are used in telecommunications and radio and TV signals. Okay. So you know that we have a law which is called law of wave propagation, which states that the wave velocity is equal to lambda, which is the wavelength. This is a Latin letter, is called lambda, times f, which is the frequency. And also we discovered that the energy of the wave is directly proportional to its frequency. So this means that the wave which has higher frequency, it will have higher energy. We discovered that as we move from radio waves to gamma rays, the energy increases. Since energy and frequency are directly proportional, so as we move from the radio waves to the gamma rays, the frequency increases. And also we discovered that the frequency and the wavelength, they are inversely proportional. So this means that the radio waves, they have the longest wavelength, and gamma rays, they have the shortest wavelength. So as we move from gamma to radio waves, the wavelength increases, right? But all of them, they have the same speed in the same medium. Their speed only changes when the medium changes. This is the reason for the light refraction, because light is just electromagnetic wave. So all of them, they propagate in space with the same speed, which is the speed of light, which is 3 times 10 to the power 8 meters per second. Okay. So what is the wave which has the longest wavelength? Radio waves. What is the color which has the longest wavelength? Red. What is the wave which has the shortest wavelength? Gamma rays. What is the color which has the shortest wavelength? Violet, and so on. So let's try to answer these questions. The boxes show some electromagnetic waves and their uses. Draw one straight line from each electromagnetic wave to its correct use. One is done for you. So, for example, gamma rays, they are used for sterilizing food. Sterilization means killing microbes. Okay? So, because gamma rays, they have the highest energy, so they have the highest ability to kill microbes. This is the reason that they are used in food sterilization. But as you can see, infrared, they have thermal effect. So they are used in cooking. In fact, infrared and microwaves, they are used in cooking. But radio waves, they are used for long-range communications. They are used for mobile signals, are used for TV and radio broadcasting. Okay. Ultraviolet, they are used also for sterilization, but they are used for fluorescent lamps. And finally, X-rays, they are used for bone imaging, just to discover if there is a bone fracture or something. So it is used for observing internal structure. Have a higher penetration power, so they can penetrate your muscles tissue and they can form images for your bones. Okay. For question B, which of these is a hazard of the microwaves? Microwave radiations, they are absorbed by the water molecules which are inside food. So the amplitude of vibration increases and the vibration between molecules increases. So the temperature of the food will increase. This is the way that we use microwave to heat our food, right? So it will cause blindness. This is not true. It will cause cell mutation. Mutation, it is a change in the DNA, and it needs ultraviolet and gamma rays to be done. Internal heating tissue, this is the correct one because this is the mechanism by which the microwave is used to heat our food. Skin burns, this is can be done by ultraviolet radiations. So one of the hazards of using microwave radiation, it causes or they cause the internal heating of tissue. For question C, state the name of the electromagnetic wave with a wavelength which is longer than the microwave. Let's move back to our revision. This is the microwave, and we said that as we move from gamma rays to the radio waves, the wavelength increases. So if you are searching for a longer wavelength than more than that of microwave, so the answer is radio wave. So radio waves is the answer. Let's move to the final question. Some questions must be answered with cross just multiple choice, okay? The Skylon Tower in Canada has an external elevators. The elevators transport people from the bottom of the tower to a viewing deck at the top of the tower. So, for question AI, an elevator moves upward at a constant speed. Constant speed means it's moving with uniform speed, means the acceleration is zero, means the sum of all forces is equal to zero. So this is Newton's first law. Which energy store of the elevator increases as the elevator moves upward? So let's revise this part. So you know that we have some energy stores like the potential energy. Potential energy is equal to mgh, and this is the energy stored in the object due to its position. When the object has a higher position, this means that the amount of energy which is stored inside this object increases. But also we have something which is called kinetic energy, which is equal to half mv squared. And as you can see, as the velocity of the object increases, the energy stored in this object due to its motion increases. And the sum of the kinetic energy and the potential energy of the object is called the mechanical energy of the object, which is constant if we have a closed system. Because if the potential energy decreases, kinetic energy will increase by the same amount if there is no loss in the energy, okay? So for this question, if we have an elevator which is moving up, this means that its height from the ground increases. And since the potential energy is equal to mgh, this means that the height increases, so the potential energy, so the gravitational potential energy increases because they are directly proportional. Chemical? No. Gravitational? Yeah, it means gravitational potential energy. Kinetic? No, because it's moving with constant speed, so its speed is not increasing. Magnetic, this is not related to magnetism. So the correct choice is B. For double I, the elevator is pulled upward. So this is the elevator. We are pulling it upward using a motor. 6 steel cables connected to the elevator to a motor. There is a motor which is just pulling the elevator. How the energy is transferred usefully from the motor to the elevator. This is not related to heating. Heating will be the form of energy in which the energy will be lost if there is a friction. Radiation, no. Electrically, no. The energy is transferred mechanically from the motor because the motor is moving. And we said that mechanical energy is equal to the sum of the kinetic energy plus the potential energy. As the elevator is moving up, its potential energy increases. And if the speed of the elevator increases, this means that its kinetic energy increases. But according to the question, the elevator is just moving up with uniform speed, so this means that this one is constant. But since the height is increasing, the potential energy is increasing. So the mechanical energy is not constant increasing, because there is work, a work is done. So this extra work is stored in this elevator as extra potential energy. So this is open system. For question B, the viewing deck at the top of the tower rotates and completes one full rotation every hour. So this is a rotating surface. So if it starts from here, it will keep rotating, and when it returns back to the same viewing point, it will take 1 hour. This is called the periodic time. Periodic time, it is the time taken by the object to complete one full rotation. The mechanism that rotates of the viewing deck is powered by a 2.2 kilowatt motor, and this is the power, but this is kilo, so you need to multiply it by 1000, so it's 2200 watt. This is the consumed energy every second. Which of these is the definition of the term power? You know that power equal to energy over time. Anything divided by time is called the rate of change. So it is the rate of energy consumption, or it is the rate of consumption of energy. So it is the amount of charge transferred? No. Is the amount of energy transferred? No, because this means that power is equal to energy, and this is true if the time is 1 second, but it is not mentioned in this choice. The rate, we said that rate means this, there is something which is divided by time. The rate means there is something divided by time. The rate of a charge transfer, this is the electric current intensity. This is not power. So the rate means something divided by time of the energy transferred. Yeah, we know that energy divided by time is power. So the correct choice is D, because power is not energy. Power is energy on one condition, when the time is 1 second. So power is the rate of energy transferred. Which of these is the same power as 2.2 kilowatt? We said that kilo means 1000, which is 10 power 3 over 1000. So it's exactly as 2200 watt. So this is wrong, this is wrong, this is also wrong. So the correct choice is D. For this question, how many seconds? So the question is asking about time, but it should be in second. Does the viewing deck take to complete one full rotation? According to the question, it completes one full rotation in 1 hour. But this question wants to change the time from hour to second. Each 1 hour contains 60 minutes, and each minute contains 60 seconds. So the answer is 3600 seconds. So the correct choice is C. So we have used these questions just to revise the topics, and as you saw, I was trying just to explain the parts which are related to the questions before answering the questions direct. Good luck.